My name is Nilesh Ramgulam. I am 21 years old. I have just completed my Bachelor of Computer Science Advanced at the University of Adelaide. I can speak English, French, which might be useful when communicating with the stakeholders of this scholarship, Creole, and I am currently located in Adelaide. I would first like to talk about my academics, namely the formal qualifications and certificate that I have. I have been admitted to the John Kennedy College for Cambridge O-level education. I was ranked 5th nationwide in physics, 1st in economics, and 1st in computer science. I then moved to the Royal College Kirpip, which is the best school in the country, and have received my Cambridge A-level education from there. I got a result equivalent to 180, and I was ranked 40th science side in my country. Then I decided to move overseas for my tertiary education and opted for the prestigious University of Adelaide, which is among the top 100 best universities in the world. I was the recipient of the Global Academic Excellence Scholarship, and I have completed my degree with a 6.478 over 7 GPA. Before getting onto my research endeavors, I would first like to talk about some work experience that I have. I was a data scientist and market researcher at a company called Verde Mauritius in Mauritius, whereby I had developed a web scraping program for the company, led developers on backend of a nationally recognized website, and created a macro program in Excel. My second job was a software engineering intern job at Harel Malak Technologies in Mauritius, whereby I have harnessed the power of Microsoft Power Apps and Power Automate to develop apps for the company and also for our clients. Then my third experience is a research intern at the Australian Institute of Machine Learning, whereby I have developed a few shot object detection workflow for the competition RoboCup at Home 2023. My supervisor during my intern was Raphael Laufrag. The first research project that I did was polyp detection, with my supervisor being Dr. Gustavo Corniro and Tim Chen for my topics project. We have successfully developed a polyp detection workflow for detecting polyps in colorectal cancer. The object detection used a PPYOLO framework and Kalman filter to track detected polyps across frames. We also use a ResNet architecture for bowel preparation score and cecum detection. This project was very successful and was on pilot testing at the Royal Adelaide Hospital. My second most prominent work was the RoboCup at Home competition. Although I'm not too sure how much I can reveal about how I did the few-shot object detection workflow and what particular model we used, because for the sake of confidentiality, I can vividly and firmly state that I have been able to develop a few-shot object detection workflow for the RoboCup at Home competition. This workflow and this model can be run on a CPU. The project won first place for category SSPL, and my team was RoboBreeze for 2023. My third most impactful research was about enhancing graph neural networks for material discovery through probability-based loss function. My supervisor for this project was Dr. Henry Lee, and through this project I have learned how a model can be uncertain about its own prediction, and how we can build a better and more robust model by modeling a prior distribution of the model's prediction. In this project, we have used deep evidential regression loss and also negative Gaussian likelihood loss in order to build a better model and more robust one. I have carried some primary research about these topics, and I have seen that this topic can be dissected into four main parts, which is fine-grained classification, explainable AI, self-supervised learning, and transformers in computer vision. Firstly, I would like to talk a bit about what I have seen in fine-grained classification. Fine-grained classification is a bit more difficult than the normal classification. This is because in fine-grained classification, we have a high interclass similarity and a high intra-class variance. So different models have been developed for the fine-grained classification, and one of the leading architecture which are being used nowadays is transformers in computer vision. Explainable AI tries to explain how a model comes up with its prediction. Models have been long thought as a black box, and even for the creator of the models, they are somehow very difficult to understand how they work under the black box. So explainable AI is a field that tries to explain how a model comes up with its solution. And it is very interesting to note that in fine-grained classification, low-level features are what are more important for distinguishing between classes than the high-level features. This goes against the dogma, and it is very interesting how we can see now that CNN are being modified to map region priors and to make prediction at low level rather than at the high level. This can be seen in the paper CMAL Net, whereby they explained how the low level features are used as experts for the high level features later and deeper into the CNNs. Self-supervised learning is an interesting field. We have a lot of data nowadays, but many data remain unlabeled. And for various tasks, we need labeled data to perform supervised learning. Self-supervised learning tries to distinguish between classes without having a human annotator to annotate all the images or annotate all the data that we have. So with self-supervised learning, we can just create classes on the fly and then use that to feed to a network. And this reduces the need for manual labor and manual annotator for our work. Transformers has been widely used in the field of natural language processing. This is because the next word of a sentence depends on the previous word, while for an image, the next pixel doesn't necessarily depend on the previous pixel. But in 2020, there was a paper called An Image is Worth 16 by 16 Words, which dissects an image into 16 by 16 patches and then feed this information to a transformer to perform classifications. This was one of the first work that used transformers in computer vision, and it had state-of-the-art results at the time on the ImageNet dataset. This is why I believe I should be considered for this scholarship opportunity. I have vast experience in object detection and few-shot object detection, and I'm very passionate about advancing the field of computer vision and willing to learn more about fine-grained image classification. I can speak French, which will help communicate with the stakeholders of the Naval Group, and I am also eligible for a potential MPhil.